this is the continuation of um, exercises 2.1 or 6.1 of Mr. John Coburn's Precalculus textbook. So without further ado, let's start at number 35. Okay, we left, our last question was number 34. Please check out the previous video. It's basically a walkthrough of everything that was answered prior to number 35. So yeah, let's start. Verify the equation is an identity using fundamental identities. A over B is A over B plus minus C over D is whatever this is to combine terms. I'm not really that strict or exact with the formulas. With the instructions stated, but then when it comes to this, let's just get straight to answering. For number 35, cosine raised to 2x, we can write that like this. So with something like that, let's say let's try making this like this. So with that, it could be said as 1 over sine x. Therefore, they're verified. I may have not explained the solution completely or very well in the short words that I have, but I hope you can see here the identities that I used. Just multiply this fraction with sine x and you get this one, and do the rest. The process is pretty easy. You just have to understand it. It's not so hard to understand. Okay, number 36. So the same process here. This time multiply this one with secant A. So you get something like this. So secant raised to 2 minus tan raised to 2 is basically 1. And secant A is the inverse of cosine A. So that's it. Number 36 is verified. Okay, number 37. Just follow along. I won't speak too much anymore. For good reason. So what we have right now is this one. This is the product of these two terms, and we can we actually have both the same denominators. So what we want to do now is let's see. We have cosine x right there. Um, hang on. Alright, I think I have to change my solution again. Biggest apologies. Number 37. Alright. You have something like this. Cosecant is 1 over sine. In other words. And you can write something like this. Sine x minus 1 over cotangent x. There. It's the perfect match with this one. Okay, let's move to number 38. Okay, the same traditional procedure. Okay, cotangent could be written as like this. Secant times sine 1 over cosine times sine over 1 cosine x minus 1 over let's say tangent yeah, this is already the same as the right side of the mentioned equation. Let's move on to number 39. Okay, we get something like this. Sine x over 1 times 1 over cosine x. Secant raised to 2x minus 1 over tangent x. It says, according to identities, that secant raised to 2 minus 1 is also tan raised to 2. And so eliminate, we get tan x. As you can see, it's the same. Alright, let's move to number 40. So cosecant, alright, find the common denominator first before starting anything else. Alright, cosecant raised to 2x minus 1 over cosine times cosine over 1. Cosine x over 1 times cosecant is sine, 1 over sine. Okay, so far so good. Cosecant raised to 2 minus 1 is equivalent to cotangent raised to 2. So with that, just cancel terms, we get cotangent x. Verified. Okay, let's move to, I'll be skipping these parts. I'm not sure how to answer these. At least I'm being honest. Unlike other people out there, tutors who assume that they know how to solve these problems, but they actually don't. They just consume a lot of time. They aren't even teaching anything relative to how we're supposed to answer these. So yeah, I'm being transparent to you right now. Let's move to number 47. This is what I can answer. The video will start from 47 all the way to 55. I won't be answering the rest here. Yeah, only until number 55. For the function f of theta and the quadrant in which theta terminates, state the value of the other 5 trigonometric functions. Okay, this is going to involve a lot of SOHCAHTOA and looking for the missing value, looking for a missing side given 3 sides. We're going to play around the values of hypotenuse, adjacent, and opposite side. Basically anything in SOHCAHTOA. So, let's start with number 47. Cosine. We all know that in SOHCAHTOA, cosine is adjacent over hypotenuse. And so, we know that in number 47, we're situated in quadrant 2. In the satchel or SATC diagram, we know that in quadrant 2, only sine or cosecant is positive. So, right now, we know that cosine is negative. Well said. Now that we know adjacent and hypotenuse, we've identified their values. What we have to look for right now is the opposite side. So hypotenuse, which is 29 minus 20 raised to 2. Opposite side for number 47 for a while. I hope you have your scientific calculators with you. We're gonna need it. The answer is 21. Okay, given that the opposite side is 21, let's look for sine. Sine theta is O over H because of so. So, opposite side is 21, hypotenuse is 29. It's positive because in quadrant 2, sine is positive. So that's the answer for sine theta. Its inverse, cosecant theta, is H over O, which is 29 over 21. It's also positive because cosecant in quadrant 2 is positive. So the rest is negative. Cosine, secant, tangent, and cotangent. Okay, I think we need a lot more space. I'll just move this one here. Right, let's keep things this way. Cosine theta is equal to A over H, which is equal to adjacent, which is 20, and hypotenuse, which is 29. Literally, what's stated here? So, secant is basically the opposite, so it's H over A. So it's negative 29 over 20. For tangent, it's basically TOA, so O over A. Opposite side is 21 and adjacent is 20. Negative, since tangent is not part of those who are positive in quadrant 2. That also goes for cotangent. It's A over O, the reciprocal or the inverse of tangent. So yeah, if you can observe recently, we've been playing with these numbers. It looks pretty intimidating at first, but you might already realize that it's pretty easy to identify the values of the remaining 5 trigonometric functions. Just look for the 3 values, given that you know the 3 sides, and you just the other 3 values are basically inverses of the first 3. The first 3, which are colloquially speaking sine, cosine, and tangent values. So yeah, let's go with number 48. Number 48, so sine is equal to O over H, which is equal to 12 over 37. We're still at quadrant 2, so in SATC, only sine and cosecant is positive. So, we have to look for the adjacent side. 37 raised to 2 minus 12 raised to 2. Adjacent is equal to 35. And so, that's right. Sine theta is equal to 12 over 37. Cosecant theta is equal to 37 over 12. Cosine is equal to A over H, which is equal to 35 over hypotenuse. The hypotenuse is 37. The inverse of cosine is, if I'm not wrong, it's secant. It's H over A, which is 37 over 35. For tangent theta is equal to O over A, which is equal to O is 12, A is 35. By the way, because we're in quadrant 2, these are the only positive. The rest is supposed to be negative. Alright. I think that's it for number 48. I'll just check the answers for a while. 35 over 12. Okay. So far, so good. Okay, let's move to number 49. So given that tangent theta is 15 over 8, say that this is TOA, so O over A, SOHCAHTOA, TOA, we look for the hypotenuse. So 8 raised to 2 plus 15 raised to 2, all under a square root, would be 17. So sine theta, O over H, our opposite side is 15, H is 17. Because we're in quadrant 3, in the satchel or SATC illustration or graph, only tangent and cotangent is positive. So sine, the inverse is cosecant, which is H over O, which is 17 over 15. These are both negative. Cosine is equal to A over H. Our adjacent side is 8 and our H is 17. Negative. And the secant would be H over A, which is negative 17 over 8. So right now, for tangent and cotangent, they're the only ones that are going to be positive values. For tangent, it's going to be 15 over 8, as stated here. And for cotangent, it's 8 over 15, the basic inverse. Okay, that's number 49. Let's go with number 50. Given that secant theta, or theta, is equal to 45 over 27, you could say that the cosine, which is the inverse of secant, is 27 over 45. Exchange the places and values of the numerator and denominator, and afterwards you have to know that this is h over a because this is a over h. What we're looking for right now is the opposite side. Opposite side is 45 raised to 2 minus 27 raised to 2. Opposite side is equal to 36. There you go. Sine theta is equal to O over h, which is equal to 36 over h. H is 45. By the way, number 50, we're given the position of quadrant 4. In SATC, only cosine and secant is inverse is positive. So this is positive, this is positive, this is negative, and as well as the inverse of sine, which is cosecant. It's negative 45 over 36. Tangent is equal to O over A, which is equal to 36 over A. A is 27. This is negative. And for cotangent, it's basically negative 27 over 36. And that's it for number 50. So far, so good. Okay. I think I'm starting to realize that I'm making a lot of mistakes in my answer key. I didn't take note about quadrant 4. So the SATC diagram, because we're in quadrant 4, it's supposed to be cosine and the secant to be positive. The rest of the values are negative. I didn't take note of that. So yeah, it's a good thing I realized that. It's pretty dangerous. Anyways, let's move to number 51. We're up to number 55. So a little more to go and we're free. Cotangent. Cotangent theta is equal to x over 5. Alright, this is going to be a lot more complicated than I've anticipated. Cotangent is basically the inverse of tangent. Tangent is TOA, so cotangent is A over O, or AO. So hypotenuse would be equal to 5 raised to 2 plus x raised to 2, which is literally just this one by itself. So right now, let's look for sine. Just kidding. Let's look for tangent first. Tangent theta is basically O over A, which is 5 over x. Okay, let's look for sine. Sine is O over h, which is 5 over h. H is 5 raised square root of 25 plus x raised to 2, or just square root of 5 raised to 2 plus x raised to 2. Which is basically x plus 5. Why didn't I think of this? Let's not make things too complicated. Cosecant is x plus 5 over 5. And cosine is equal to a over h. A is x, then h is x plus 5. And so secant is equal to x plus 5 over x. I think. Yeah, I'm pretty sure. Okay, I think that's it. Those are the 6. One has already been given. Let's move to number 52. So given cosecant is equal to 7 over x with pi in quadrant 2. By the way, number 51, it's quadrant 1, so all is positive. So this is positive, 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 positive. In number 52, it's quadrant 2, so in SATC, only sine and cosecant is positive. So this is positive. Cosecant is basically the inverse of cosine, which, inverse of sine only, which is h over o, if I'm not wrong. Sine theta is equal to o over h, which is equal to x over 7. And so cosine theta is equal to a over h. By the way, we have to look for adjacent first. Adjacent is equal to the hypotenuse, which is 7 raised to 2, minus the opposite side, which is this. So adjacent is equal to 7 minus x. So 7 minus x over hypotenuse, which is 7. That's the final answer for cosine. Cosine, the inverse is secant. So we have something like that. And for tangent, we have o over a, which is x over adjacent. Adjacent is 7 minus x. X over 7 minus x is the tangent, and the inverse is the cotangent, which is this. That's it for number 52. Number 53. Given that sine theta is equal to negative 7 over 13, which is equal to o over h. Given quadrant 3, in SATC, quadrant 3 is only tan and cotangent is positive. So cosecant is equal to basically the inverse of sine, which is negative 13 over 7. Cosine theta is equal to a over h, which is equal to hang on, we have to look for adjacent first. You cannot forget that part, otherwise the entire mission is completely basically we're back to alpha. So 13 minus 7, which is 6, I think. Wait a minute. According to my calculator, it's 2 times the square root of 30. Not sure, but let's give it a try. So cosine is 2 times the square root of 30 over hypotenuse, which is 13. Ow, my back hurts. I'm sorry. Cosine, the inverse of cosine is secant, which is 13 over 2 times the square root of 30. So these are all negative. Now let's go with the tan and cotangent. Tangent is equal to o, negative 7, over a, which is 2 times the square root of 30. This is positive because in quadrant 3, tangent and cotangent is positive. So we have something like this. Okay, number 54. Okay, cosine. For number 54, we have to look for the opposite side. The outcome is this. So, the inverse of cosine is secant, which is equal to 25 over 23. The basic opposite. Yeah. Sine theta is equal to O over H, which is equal to 4 times the square root of 6 over hypotenuse, which is 25. By the way, quadrant 4 SATC, only cosine and secant are positive. The rest is negative. So sine is negative, these two are positive. Cosecant is negative. H over O, tangent zeta is equal to O over A. O is this one, and A is 23. Cotangent is equal to negative 23 over 4 times the square root of 6. There you go. That's number 54. So far, so good. Okay. I'm seeing many mistakes in my answer key. So many mistakes. But at least right now, I think these are correct. I can at least give certain assurance. Okay, let's finish this. This is our last question. Number 55. Secant theta is equal to negative 9 over 7, which is equal to, because secant is the inverse of cosine, which is A over H. This is H over A. So let's look for the opposite side. So 9 raised to 2 minus 7 raised to 2. We get 4 times the square root of 2. With that, we have the opposite of secant is cosine, which is negative 7 over 9. Quadrant 2, this is where sine and cosine, where sine and cosecant are positive. SATC, yeah. So let's look for sine theta. Sine theta is O over H. O over H, our O is 4 times the square root of 2. H is our 9. This is positive because in quadrant 2, sine is positive. As well as its inverse, the cosecant. So yeah, let's look for the tangent. Tangent is equal to O over A. O is 4 times the square root of 2, and our A is 7. This is negative. Cotangent theta is equal to negative 7 over 4 times the square root of 2. Okay. Yes, sir. I think we finished it. Alright. We're done, I think. I'm pretty sure we're done. Okay. I hope this video helped. I'll see you in the next video. It's going to be about more exercises in Mr. John Coburn's Precalculus textbook. We finally finished exercises 6.1 or exercises 2.1 in other books. So yeah, I'll see you in the next videos to come. Thank you for watching.